When we talk about enterprises network, we will have a particular design called hub and spoke. Have you heard about hub and spoke? The word hub and spoke? Have you heard about hub and
No,
spoke?
no, I have not heard.
Okay. Hub and spoke. Even in the previous class, I mentioned this word hub and spoke. It's like, if you take a cycle rim or a bike rim, you have a hub in the middle and you got spokes. Yes or no?
Yes.
Likewise, we have network, a router. Sorry. We got a router connecting to many other routers like this. We call this as hub and spoke design. In networking, we can see this in most of the places, hub and spoke design. So, whenever you have hub and spoke design, there is some consideration need to be done. If EIGRP is your routing protocol, what is that? Let's see. First is scalability issues will come. Scalability issues will come.
Okay.
What is scalability issue? Whenever there is a change in one of the spokes, that will be flooded to hub and hub will flood to all other spokes. So when I say spokes and hub, it is not just one router, many routers.
Yeah.
Like this. So when there is a small change happening in this link, it will go to everyone, and all the devices connected to all these routers. So this is not acceptable because this is going to increase the bandwidth, CPU consumption, etc. This is going to decrease the efficiency of our network. See, the quantity of routing information exchanged between the peers need to be reduced. For that, we need route summarization. This is one method. When you do summarization, we can reduce the flooding of advertisements. For example, when I have some networks like 10.1.0.0, 10.2.0.0, 10.3.0.0, 10.255.0.0, when we don't do summarization, how many route updates will go?
That many, like 1, 2, 3, a number of updates, right? Yeah.
255. 251, 255 lines of updates will go. But when I do summarization, it is going to be 10.0.0.0, just one instead of 255. So summarization definitely reduces the not only the bandwidth on the receiving router, the space that routing table, that is the bytes, amount of bytes that routing table going to consume will also be reduced. Not only that, the CPU utilization will also get reduced. Yeah. So summarization is very good. More than that, we also need to keep control of number of routers that get involved when there is a change in the topology. When a change happens, how many routers the impact is need to be controlled. It should not be too many routers getting disturbed. For example, if there is one employee who is doing all the work, most of the work, and if that employee leaves the company, then the entire project will get impacted, because he was the one who is actually active, honest, knowledgeable, skilled person. So now many will get affected because that one person was doing the job of many. You know, that one person leaves the company, many will get impacted. That's not good. Likewise, in networking, if any change occurs, the change should not involve or include many routers. That change should be, say, for example, if this link goes down, will this router get involved? No, because we have summarized. So the number of routers that must be involved when the topology change occurs is minimized here. If you don't do summarization, it would have gone here when this link goes down. Not only here, if you have many other routers, it will go to all. So summarization is one best method to reduce the number of routers that are going to be involved when a topology change occurs. That's good. Next is, see, when we don't do summarization, it is going to impact the scalability. So likewise, depth of topology. How many number of routers, hops, the information must travel to reach all routers. So when a change happens, how many routers the change is going to be flooded? Depth.
Depth of topology.
See, summarization is actually reducing the depth of topology. Yes or no? Because you did summarization, the very next router don't receive the information change. As a result, the depth is being reduced. It should not be too deep. If it is really needed, you may have one or two hops impacted, affected, but not all. So next is, whenever you have alternate paths, if one path goes down, you will have immediately the alternate path supporting you. What if you don't have alternate path? Then again problem starts. When you don't have alternate path, then the router will start querying the other neighbors. What if the neighbor also don't know? So these are all the factors that influence EIGRP scalability. We need to keep an eye on all this. One thing that we have already learned to control this is summarization. Summarization, we have already seen, isn't it? Have we done summarization? We have done two types of summarization. Global summarization as well as the interface level summarization. Yeah, so summarization is one thing. The other thing is alternate paths. When we have hub and spoke design, which I started this class with the with one design called hub and spoke. In hub and spoke design, you will have alternate paths, but there are some caveats. There are some problem comes along with that, for which we need to do something called STUB. We are going to learn in this chapter a topic called EIGRP STUB. That's why they are putting some foundation here. Why do we need EIGRP STUB? EIGRP STUB is needed whenever there is a hub and spoke design, and whenever there is some paths available, more than one path to a destination, or may not available. So let's see what it is. Go inside now. You see, when will EIGRP send a query? What is query? Query is a doubt. when the primary route goes down, if there is no backup path, immediately the router will put the destination route into active state. It will put the route into active state and it will start sending the query asking for the route to all the neighboring routers except the interface of the successor. What does that mean? See this picture. This is the successor path to reach a network called 10 dot some network here. Let's say 10.12.0.0/24. This is the successor path. Successor means what? The best path. Now, when the best path goes down, B will start querying all neighbors connected via all interface.
Yeah.
You understand now this word, this line. Queries are sent to all neighbor routers on all interface except the interface of the interface to the successor. See, successor was the best route. That only gone down. Why it will query again the same path? It won't query. It knows that it has gone down. It got a message saying that it has gone down. So it is going to send the query message to every other router that are connected. See, the query that goes like this here, no, comes back here. And then again comes back here. And then query that went like this here comes back, goes here, comes back. You know, this is a very big chaos. It's looping. Can you see that? Everyone is start querying the same thing. This is what I call it as hub and spoke. Do you see a hub and spoke here? Is it not a hub and spoke? It is. So queries are sent to all neighboring routers on all interfaces except the interface to the successor. Now, if the neighbor do not have the route, see, query is sent here, but
sir,
this
I
neighbor
lost
do
you.
not have the route.
Hello?
You are querying, but it don't know the route.
Yes.
What it will do? Okay, how long? When C don't know, it comes to A. If A also don't know what it will do, it will query to D, E, again to B, because they're all its neighbor. But already D has got a query, same query. D also don't know. It will also send to A. A will send to C. C will send to B. See how it is looping. You see that? It's looping, looping. This is going to cause problem. You remember we saw the factors that are impacting the scalability. One is the depthness. You see how deep it is going. It's keep on looping, right? So this needs to be controlled. Do you follow me? Okay. So if neighbor do not have the lost route information, the queries are sent to their neighbors. It will be keep on spreading. In case if one of the router has got an alternate route, it will answer the query. In that branch of network, the query will not spread again. Only if only when there is a answer for the query is known. If answer is not known, then it will be keep on going. You got it? So depthness of topology is what we are seeing. There are too many routers involved in just one small change, which is not good. So this need to be prevented. See how long this will go. It will be keep on going, but B never gets a reply because no one knows Assume there is no alternate path to that through that network. Let's say the network is 10.12.0.0/24. It's here, but the path is gone. No one else is connected there. No one is connected like this. No one is connected. So no one is going to respond. But let us say somehow this guy is connected. Assume there is a connection, but it's a very slow connection. So some router here is responding, saying, I know the path. It comes to B. But B won't accept it. Sorry, B will accept it, but B won't use it. You know why? Because B has already sent query to C also. C, D, and A as well. So B will wait for them also to respond, but will they respond to you? Will they respond? No, because they are no way connected. Because they are not responding, B will wait thinking C may bring a better route, A may bring a better route, D may bring a better route. So it is waiting for them also to bring so that it can compare with E, response and decide. You understand? And after 3 minutes of waiting, how many? 3 minutes. After 3 minutes of waiting for C, D, and A, it will discard C and D and A from the neighbor list. Why? Only then it can use E's given route. As long as C, D, and A is available, it cannot use what E has given. You understand? So, because I have queried C, D, and A, that may bring a better route. So it has to wait. But they are not going to come, so you cannot keep waiting. EIGRP is designed to wait for 3 minutes. After 3 minutes, it will discard all the neighbor who has not responded. What is discarding? Remove from the neighbor. If it removes from the neighbor, it is going to make a big impact in the network. Because every network that was earlier going via C and D and A need to be removed from the routing table from all the routers. It's going to be a big disruption. So after 3 minutes, it removes the neighbor and then start using E given route. After that, it will start forming neighbor freshly with B and with C, D, and A. You understand? So again, it forms neighbor. Again, it is going to be disruptive. It is going to tell everyone that there is a new router, but they are not really new router. So EIGRP discards and it forms neighbor again. Yeah, this is a very big impact in the enterprises network. Need to be controlled. How to control? Very simple. Whenever you have hub and spoke topology, you need to go to all the spokes. These are all spokes routers. You need to go to all the spokes router and tell what you are capable of. So that B will query only what you are capable of. It won't query that you do with the things that you do not know. You understand how the problem is solved? You understood or not? C, D, and E and A, C, D, E, and A, you need to configure STUB. When you configure STUB, what will happen? C, D, E, and A will send a special message saying, I am capable of doing only these things. I know only these networks. If you have any question, you can query. The rest of the networks don't query me. That is what called a stub. When you configure stub,
Yeah.
you can avoid that struck inactive scenario. What is struck inactive? I told you when the network
Mm-hmm.
goes down, when the route is lost, it goes to active state. It goes to active state and it got stuck for how many minutes?
Mm-hmm.
3 minutes. 3 minutes
Mm-hmm.
they were all stuck. To avoid this waiting of 3 minutes,
Mm-hmm.
to avoid the struck inactive scenario, these routers you need to go and configure stub. When you configure stub, what will happen? Stub routers will send a special peer information package to all the neighboring routers reporting their status as a stub router, meaning, hey, I'm a stub router, meaning you can ask only these networks. Don't ask me all other thing. I cannot respond to you. So beforehand it goes and tells what it can support. So when the successor route
Mm-hmm.
goes
Yeah.
down, it will know whom to query and whom not to query. B will know whom to query and whom not
Once
to
again,
query. Did you
how it
understand
reduces.
this?
Mm-hmm.
Now you read this paragraph, 4 paragraphs. I'll give you 2 minutes. Read it by yourself. Then if you have any question, let me know. See, when you don't unnecessarily query someone who do not know, you can avoid spreading. You see, when the
Mm-hmm. Yeah. Yeah. Everybody. Yeah. CPUs
if
use it.
the neighbor do not know about the lost route,
Yes.
what it will do? It will keep sending to all neighbors. When you keep sending to all neighbor, what happens? Bandwidth is consumed, CPU is consumed, all those things can be reduced. So EIGRP stub routing feature improves the network scalability, reduces resource utilization, and simplifies the remote router configuration. Stub routing is commonly used in hub and spoke topology. Now, a stub router will send a special peer message to all the neighboring routers to report their status as a
Yeah.
stub. The neighboring router that receives the packet informing it of a stub does not query the stub router for any routes. You see, it is very important.
Mm-hmm.
When I ask you
Yeah.
something, hey, do you know Greek? And if you say you don't
Mm-hmm.
know, or you know, then problem solved. Okay, he knows. He don't know. Problem solved. I no need to wait for you now because you have already answered. But when I send five of my friends, hey, do you know Greek?
Mm-hmm.
And if all five of you are silent,
Mm-hmm.
if all five of you want to help me, so what you did is you sent it to
Mm-hmm.
your friends without answering me because you do not know.
Mm-hmm.
You didn't answer me. You don't want to answer me, no. You want to answer me something responsible. So what you did is instead of saying no, you sent it to your friends, and your friends also don't know. They
Mm-hmm.
are sending to their friend, and we are all waiting. I am waiting, you are waiting, your friend is waiting, your friend's friend is waiting. It is
Mm-hmm.
going on spreading the whole Kerala and Karnataka and Tamil Nadu and Andhra Pradesh, but I'm still waiting.
Mm-hmm.
This need to be stopped. So instead of you sending the query to again next neighbor, if you would have told me, no, I don't know Greek,
Mm-hmm.
then problem solved.
Mm-hmm.
I would have removed the route from the routing table. I will not put it into the active state, isn't it? That is what stub is.
Mm-hmm.
Now the stub is of five types. The stub is of five
Mm-hmm.
types. One is stub connected.
Mm-hmm.
When you configure a spokes router with stub connected, that stub router will take
Mm-hmm.
responsibility only for those connected networks.
Mm-hmm.
If that router learned some network from other routers, it won't take responsibility for that network. Whatever is connected, it will take responsibility. For other networks and other networks learned in the routing table from other
Mm-hmm.
neighbors, it won't take responsibility.
Mm-hmm.
So when you configure a spokes router as a stub, it will say, hey, these are the networks connected to me. You can ask about this. Other things don't ask me.
Mm-hmm.
Next is stub summary. What is stub summary? The router which you configure as a stub summary
Mm-hmm.
will take responsibility only for those summarization that you have done on the router. It
Mm-hmm.
won't even take care of the connected network.
Yeah. Mm.
It will go to the hub router and say, hey, this is the summary network I have. Anything about this you ask me, I'll tell to you. Don't ask me anything else,
Mm-hmm.
any other thing. Okay. So that is
Mm-hmm.
stub summary. Now, if you want both connected and summary, then you simply
For.
configure stub. Both will be getting enabled. How many types we have finished?
Mm. Okay. Mm.
No. How it is 4? This is 1.
Mm-hmm.
This is 2. This is third. Third is connection of these two.
Summary. Mm-hmm.
When you configure EIGRP as simply stub, it will take
Yeah.
responsibility for connected as well as summary. Please understand. If you say
Yeah.
EIGRP stub connected, it is going to take responsibility only for connected network. If you say EIGRP stub summary, it will take only responsibility of summary network. If you don't say connected or summary, it will take
Mm-hmm.
responsibility
Yeah.
of both. If you simply say this one and hit enter, it takes responsibility of connected as well as summary.
Mm-hmm.
You got it?
Mm-hmm.
Next, stub static. EIGRP stub
Yeah.
static. What it is, if you will have a static route which is
Mm-hmm.
redistributed in EIGRP, you got a static route
Mm-hmm.
that is redistributed into EIGRP. Only that static redistributed route will be taken responsibility.
Mm-hmm.
Router will not take
Yeah.
responsibility of connected, summary. It is going to take responsibility only for that static route which is redistributed into EIGRP. You got it?
Mm-hmm.
Finally, EIGRP stub receive only. What it is,
Mm-hmm.
when you configure a router as receive only, it will not send any route. It will not take responsibility for any routes. It will say,
Receive only, like,
don't ask me
in
anything.
which situation it will be in receive only? Like, at what situation will
But
configure?
if you give, I'll take. I'm
Okay.
only receive only. You understand?
Mm. So will it form the
Very simple.
neighborship
I
with
don't want to advertise, that's all.
other?
But I want to learn.
Mm-hmm.
Whatever the hub router gives, I want to learn.
Okay. Okay.
Whatever I have, I don't want hub router to learn. Maybe it will
Mm-hmm.
form neighbor, but it won't give any routes. If someone wants to come and
Mm-hmm.
reach the network, then they have to use the static route and come. But this router receives everything. This will use EIGRP route, but the other guy should use only
Mm-hmm.
static route. Now, after configuring stub, you see there is no scribbling like this. Before STUB, it was like this.
Step.
But after STUB, it is very neat. See, what is this arrow mark telling you? It tells that all three routers C, D, and E goes to the hub router B and A and report itself as a stub.
And
Now,
configuring stub as
I'll give
static,
you
so it will
minutes.
advertise only
Go
the
through this.
static
There
route.
are two type of stub here
So
with example.
statically,
If you have question, ask me.
IP route.
Go through the next two.
Yeah. Yes.
You see,
Yes, correct.
there is a static route, and that is also
They are connected,
redistributed.
but they are not static.
So only that route is getting advertised.
Sir, this redistribute static.
Yes or no?
1001
This is
to
static.
55
All others are not static. They are connected.
Yes, correct. Yes,
It won't advertise. Okay, read the next one.
Okay, yeah, got it. If
That's the metric, K values. You remember 5 K values of EIGRP. So for the static route, you need to give some
So A need to have
EIGRP
static route to the
bandwidth,
network behind B to reach
delay,
the
load, MTO. Next.
Yeah. So static route, next hop will be router B.
Right? A will not receive anything from B. If A wants to reach the network behind B, A should write a static route to come here. They will form neighbor, but B won't give anything. B, yes. So stuck in process is 3 minutes. We call it as what? SIA, stuck in active. In 3 minutes, if queries are not answered, then the neighbors are going to be discarded. Neighbor relationship will fail.
Okay.
And it will start resetting all the neighbors. Neighbors will be removed and reset the neighbor. Packet, it needs to establish neighbor once again. This is going to be a queries are unicast.
Okay.
So
query means like it's asking for the routes, no?
It will,
yeah. Okay.
It will ask all the neighbors. It's a query packet. It's not a hello packet. It's a query packet. Network route which is lost. Now you see, same thing what I said, it is explained. If you don't have stuck in active configured, it will send query, wait, and after 3 minutes it will reset the relationship. Whereas if you have the thing configured, what? If you have configured STUB, every router is going to send what they are capable of, and it will query only those networks that are possible to answer by B. Now, there is another concept called goodbye message. What is goodbye message? For example, this is the successor path to some network. Okay. Now, if something went wrong here, this router will send a goodbye message saying, don't wait for me to give a route. My route is gone. Don't come through me. Find some other way. You understand? B will send them a message, special message with all K values 255. If you multiply 255 by load, what will happen? More load. Then A will say this route is bad. I'll go through other route. You understand? So goodbye message is nothing but sending a bad metric for the path which earlier was a good metric. So that A will not prefer to go via B. It will immediately switch to the feasible successor and make the feasible successor as a successor. Did you understand this? That's the end of the whole EIGRP story. What is left is EIGRP with IPv6 is left. And then EIGRP newer version, you can also use names as a process ID. Okay, this is only summarization. Fine. So those things we will cover.